You think you know survival food. Maybe you've heard about eating bugs or tree bark when times get rough, but 50,000 years ago, your Neanderthal cousins were cracking bones for marrow, hunting cave lions, and turning poison plants into dinner. These weren't desperate moves. This was precision nutrition that kept them alive through ice ages that would kill you in weeks. What did they actually eat? How did they turn death into calories? And which of their survival tricks still work today? If you value documented prehistoric history like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from archaeological evidence and paleobotanical studies. Now back to the story. Number 1. Bone marrow from megafauna. 45,000 years ago in the Périgord caves of France, Neanderthals weren't just eating mammoth meat. They were smashing femur bones with stone hammers, extracting the fatty marrow inside. 1 cubic centimeter of fresh marrow delivers 93 calories, more energy-dense than most meat. At Combe Grenal, archaeologists found mammoth bones with systematic percussion marks. The marrow cavity was always targeted first. 17 different bone fragments show the same technique repeated across generations. They knew exactly where to strike. The marrow provided essential fats their lean game meat couldn't deliver. When winter hit and hunting failed, stored bone marrow meant survival. Archaeological evidence shows they could extract every gram from a single mammoth leg bone, enough calories to feed a family group for 3 days. The technique wasn't random violence. At Abri-Pataud, researchers found specialized bone hammers weighing exactly 2 to 3 pounds, heavy enough to crack thick cortical bone, but light enough for precise control. The impact points cluster within 2 inches of optimal marrow access zones. Temperature mattered. Fresh bones at body heat cracked cleanly. Frozen bones shattered, destroying the contents. They waited for the right moment after each kill, when rigor mortis hadn't yet stiffened the carcass, but body heat remained. Marrow extraction happened within 6 hours of death across 14 different kill sites. The fat content averaged 78%, comparable to modern butter. During the last glacial maximum, when temperatures dropped to -40 degrees Celsius, this concentrated fat prevented hypothermia deaths that claimed less adapted human populations. Cold, fat, life. Number 2. Cave bear meat in alpine winters. 38,000 years ago in the Austrian Alps, Neanderthals were hunting animals that outweighed them 3 to 1. Cave bears stood 4 feet at the shoulder and weighed 800 pounds. At Repollestola Cave, bone deposits show systematic butchering of adult cave bears during winter months. The cut marks target high-fat areas, shoulder joints, rib connections, skull base where brain tissue concentrates. 1 cave bear provided 12,000 calories of meat, plus another 4,000 in fat and organs. Neanderthal hunting groups averaged 6 individuals. That's 2,600 calories per person, enough for 2 days of hard winter survival. The femur bones show spiral fractures, meaning they cracked them fresh for marrow while the meat was still warm. 17 cave bear skulls from the site show identical foramen magnum damage. They knew exactly how to access brain tissue. Bear hunting required coordinated ambush tactics. At Drachenloch Cave, stone spear points were found embedded in bear vertebrae, evidence of pack hunting strategies. They targeted hibernating bears in winter dens when the animals were sluggish from months without food. Den sites were located by tracking fresh scratches on cave walls and following scent trails invisible to modern humans. The bears were cornered using firebrands, then killed with multiple spear thrusts to vital organs. Butchering began immediately in the cave to prevent scavenger competition. They carved meat into strips and dried it over smoky fires within the cave mouth. Preserved bear meat could feed a group for 2 weeks. Fat was rendered and stored in cleaned bear stomachs, waterproof containers holding up to 5 gallons of concentrated energy. Some caves contain the remains of 30 bears killed across multiple winters, suggesting the same hunting grounds were used for generations. Number 3. Cooked roots and tubers from floodplains. 42,000 years ago along the Dordogne River, Neanderthals were digging up wild potatoes and turning bitter roots into edible calories. Starch granules embedded in dental calculus from La Chapelle-aux-Saints show they consumed underground storage organs, roots, bulbs, tubers. Raw wild potatoes contain toxic glycoalkaloids that cause cramping and nausea. Cooking neutralizes the poison. Hearth remains at Pech de la Zay show systematic burning of plant materials alongside stone tools designed for digging. Wild potatoes deliver 112 calories per 100 grams when cooked. A single floodplain could yield 40 pounds of tubers in autumn, enough carbohydrates to sustain a group through lean hunting periods. They dug with sharpened wooden sticks, following seasonal flooding patterns that concentrated root vegetables in river bends. The digging sticks weren't crude tools. At Schoningen, preserved wooden implements show sophisticated craftsmanship, fire-hardened points, ergonomic grips shaped for extended use, lengths calibrated to soil depth. Wild tubers grew deepest in sandy river deposits, where spring floods deposited nutrients. They followed hydrological cycles, timing collection for late summer when tubers reached peak starch content. Experimental archaeology shows Neanderthal digging techniques were 40% more efficient than random excavation. They read landscape signs, specific plant markers, soil coloration, seasonal flooding marks on rocks. One experienced digger could harvest 15 pounds of tubers in 3 hours. The roots were wrapped in wet leaves and buried under coals overnight. Slow cooking converted toxic compounds into digestible starches while preserving essential minerals. Some tubers were sliced and dried on flat stones, creating portable carbohydrate stores that remained edible for months. Number 4. Raw shellfish and crustaceans from coastal zones. 50,000 years ago on the Iberian coast, Neanderthals were prying open mussels with stone wedges and eating them alive on the beach. At Cueva de los Aviones and Cueva Anton, shell middens contain thousands of marine mollusks with fresh fracture patterns. They ate them immediately after collection. Fresh mussels provide 24 grams of protein per 100 grams, plus essential omega-3 fatty acids their inland diet lacked. The shells show systematic opening techniques, always at the hinge point, always with lateral pressure. 14 different species represented. From blue mussels to cockles to razor clams, they collected during spring tides when exposure was maximum. One tidal pool could yield 5 pounds of shellfish in 2 hours. The shells were discarded in organized piles, suggesting they returned to the same collection points across seasons. Collection timing followed lunar cycles. Spring tides occurred twice monthly when moon and sun aligned, creating maximum tidal range. Low tide exposed shellfish beds for 4 hours, enough time to harvest but requiring precise scheduling. They developed specialized tools for different species. Flat stone wedges for mussels, pointed picks for periwinkles, curved scrapers for limpets attached to rocks. Some tools show wear patterns from thousands of uses. The shells were opened with surgical precision to avoid cutting valuable meat inside. Broken shell fragments could slice fingers, causing infections that ended careers. Master collectors could open 40 shells per minute without injury. They understood seasonal reproduction cycles, collecting during months when shellfish were fattest, avoiding spawning periods when meat quality dropped. Coastal groups established seasonal camps within walking distance of productive beds, following established routes marked by cairns and distinctive beach landmarks. Tide, shell, protein. Number 5. Bird eggs stolen from cliff nests. 39,000 years ago in Gibraltar, Neanderthals were scaling vertical rock faces to raid seabird colonies during nesting season. Eggshell fragments from Gorham's Cave show they targeted large seabird species, cormorants, gannets, auks. A single cormorant egg contains 130 calories, plus complete proteins and essential fats. The fragments show they cracked eggs carefully to extract contents without losing liquid. Cliff nesting birds lay between March and June, when other protein sources were scarce after winter. Neanderthal groups could harvest 200 eggs in one morning raid. That's 26,000 calories, enough to feed 8 people for 2 days. The cave floor contains eggshell deposits 3 inches deep, representing decades of seasonal exploitation. Cliff climbing required specialized techniques. At several Mediterranean sites, researchers found grooved handholds carved into limestone faces, evidence of engineered climbing routes used across generations. The Neanderthals climbed barefoot for better grip. Timing raids for dawn hours, when adult birds were away feeding at sea. Nests were systematically emptied without destroying the structures, allowing birds to re-nest later in the season. They carried eggs in woven grass baskets lined with soft moss to prevent breakage during descent. Some climbers specialized in the most dangerous routes, accessing colonies on sheer faces that modern rock climbers would rate as technically challenging. Accidental falls killed an estimated 1 in 20 egg collectors based on skeletal trauma evidence from coastal caves. The protein was worth the risk. Fresh eggs provided complete amino acid profiles missing from their primarily meat-based diet. They ate eggs raw immediately after collection or buried them in cool sand for later consumption within 24 hours. Number 6. Cooked pine inner bark during winter famine. 41,000 years ago in the Cantabrian Mountains, Neanderthals were stripping bark from pine trees and roasting it over fires when snow blocked hunting routes. Phytolith analysis from El Sidron Cave shows consumption of inner pine bark during winter months. Fresh pine cambium contains natural sugars and vitamin C, essential for preventing scurvy during months without fresh plant foods. They peeled bark in spring when sap flow was highest, then dried strips over low fires. Cooked pine bark provides 43 calories per 100 grams, plus fiber that aided digestion of heavy meat diets. 10 pounds of processed bark could sustain one person for 5 days during total hunting failure. The technique required precise timing. Too early and the bark was bitter, too late and nutrients dropped. 17 separate hearths at the site show systematic bark processing across multiple winter seasons. Bark selection followed strict criteria. Only trees between 6 and 12 inches diameter provided optimal cambium thickness. Younger trees had insufficient bark. Older trees developed thick, inedible outer layers. They targeted Scots pine and stone pine species that grew at specific elevations between 1,000 and 2,000 meters. The peeling technique preserved tree health. They removed bark in vertical strips no wider than 6 inches, leaving growth tissue intact. Trees could survive multiple harvests across years. The inner bark was processed immediately after removal, using sharp stone scrapers to separate edible cambium from woody fiber. Moisture content had to remain above 60%, or the bark became too tough to digest. They roasted strips on hot flat stones, turning them constantly to prevent charring. The finished product resembled leather jerky, portable and resistant to spoilage. Emergency bark caches were hidden in rock crevices marked with stacked stones, creating survival food stores accessible even under deep snow. Number 7. Fresh fish caught with wooden spears in shallow rivers. 44,000 years ago along the Weser River, Neanderthals were standing waist-deep in cold water, spearing salmon during autumn spawning runs. Wooden spear tips from Schöningen show they shaped fire-hardened points specifically for fishing. Salmon runs occurred between September and November, when fish concentrated in shallow spawning areas. A single Atlantic salmon averaged 12 pounds and provided 2,000 calories of high-quality protein plus essential omega-3 fats. The spear points show wear patterns consistent with striking fish in water, smooth grooves from scales and fins. During peak runs, they could spear 30 fish per day. Fish bones from Abri Patod show systematic filleting, spine removal, head separation, rib cutting. They processed catches immediately because fish spoil within hours without refrigeration. Fishing spears were engineering marvels. The wooden shafts measured exactly 8 to 10 feet long, optimal for striking fish in knee-deep water while maintaining balance. Points were carved from yew wood for flexibility and fire-hardened to prevent splitting on impact. The tips featured backward-facing barbs carved as integral parts of the shaft, not separate pieces that could break off. Spear throwers practiced year-round using target stones in shallow pools, developing accuracy essential for success during brief spawning windows. They understood fish behavior, positioning themselves downstream of spawning beds where exhausted salmon concentrated. Multiple spearers worked cooperatively, driving fish toward shallow areas where strikes were easier. Fresh fish were gutted immediately and packed in snow or cold stream water. Surplus catches were smoked over low fires using aromatic woods that prevented insect infestation. Dried fish provided portable protein for winter months when rivers froze solid. Strike, silver, flesh. Number 8. Cooked mushrooms and fungi from forest floors. 37,000 years ago in the Black Forest region, Neanderthals were collecting bracket fungi from dead trees and roasting them over fires to neutralize toxins. Spore analysis from Whole Fells Cave shows they consumed polypore fungi during autumn months when other plant foods were scarce. Raw bracket fungi contain compounds that cause stomach upset in humans. Heat breaks down these irritants while preserving nutrients. Cooked polypore provides 18 calories per 100 grams, plus trace minerals absent from meat-heavy diets. They collected fungi using wooden digging sticks, targeting trees killed by storms or disease. One dead oak could yield 5 pounds of bracket fungi. The mushrooms were dried over low fires, creating stored food that remained edible for months. Charcoal patterns show they maintained specific temperatures, hot enough to cook, but not so hot the fungi burned. Fungi identification required specialized knowledge passed between generations. They distinguished between dozens of similar species, some edible and others potentially fatal. Master collectors could identify bracket fungi by texture, smell, color patterns, and host tree species. They avoided fungi growing on certain wood types that concentrated toxins. Collection happened during specific weather windows after autumn rains, when fungi reached peak moisture content, but before insect infestation. The processing technique involved slicing thick brackets into strips, removing woody portions that couldn't be digested. Low-temperature drying over smoky fires took 12 to 18 hours, requiring constant attention to prevent overheating. Properly dried fungi could be reconstituted in winter stews, providing essential minerals and adding flavoring to otherwise monotonous meat diets. Some fungi were ground into powder and mixed with fat to create concentrated nutrition bars that remained stable for months. Number 9. Raw liver from freshly killed large game. 43,000 years ago at Spy Cave in Belgium, Neanderthals were cutting into mammoth carcasses within minutes of the kill, consuming fresh liver while the blood was still warm. Microscopic analysis of stone-cutting tools shows residue from liver tissue. Fresh liver provides 290 calories per 100 grams plus vitamin A, iron D and B-complex vitamins essential for Arctic survival. They ate liver raw because cooking destroys heat-sensitive vitamins their bodies required. A mammoth liver weighed 30 pounds, enough fresh organ meat to feed 12 people. The butchering sequence always targeted liver first. Before rigor mortis set in, cut marks on mammoth ribs show they opened the chest cavity with systematic precision, following the same anatomical knowledge across different kill sites. Liver consumption followed strict hierarchical rules. Senior hunters ate first, followed by pregnant women, then children, finally adult males. This distribution pattern maximized survival during harsh winters, when vitamin deficiency could kill within weeks. They understood that liver contained concentrated nutrients absent from muscle meat. Iron prevented anemia that plagued other human populations living at high latitudes. Vitamin A maintained night vision crucial for winter hunting success. The liver was consumed within 2 hours of death when vitamin content peaked. Beyond that window, decomposition began destroying essential nutrients. They carried special curved knives designed specifically for organ removal, honed to surgical sharpness. The cutting sequence opened the diaphragm first, then lifted the liver intact without puncturing the gallbladder, which would contaminate the meat with bitter bile. Each mammoth kill fed an extended band for days, but the liver provided survival insurance against nutritional diseases that eliminated less knowledgeable groups. Number 10. Seeds and nuts cached in underground pits. 40,000 years ago in the Rhine Valley, Neanderthals were collecting hazelnuts in autumn and burying them in lined pits for winter consumption. Storage pits at Königsauer contain thousands of hazelnut shells with deliberate cracking patterns. Each nut provided 9 calories of concentrated fat plus protein. They lined pits with bark to prevent moisture damage and covered caches with stones to mark locations under snow. A single cache contained 200 pounds of nuts, enough stored calories to sustain a family group through 6 weeks of winter hunting failure. The nuts were cracked with precision, always at the narrow end, always with controlled force to preserve maximum meat. 13 separate caches across the site suggest they maintained multiple food stores as insurance against seasonal scarcity. Cache construction required engineering precision. Pits were dug exactly 18 inches deep, below the frost line but above groundwater levels. They lined holes with interwoven strips of birch bark that created waterproof barriers. Nuts were layered with dried grass to prevent compression damage. Stone covers weighed exactly 30 to 40 pounds, heavy enough to deter scavengers, but light enough for humans to remove. Cache locations followed systematic patterns spaced every 500 meters along river terraces, creating supply networks accessible during winter travel. They tested nuts before storage, discarding any with insect holes or fungal damage that would spread during storage. Fresh hazelnuts contain 37% fat, higher energy density than most wild plant foods. Properly cached nuts remained edible for 18 months. Some storage pits show evidence of multiple use across decades, suggesting cached food systems that supported stable populations through unpredictable climate fluctuations. Crack, store, survive. Number 11. Cooked snails and land mollusks from limestone areas. 36,000 years ago in the Pyrenees, Neanderthals were collecting land snails after spring rains and cooking them in shell over hot coals. Shell middens at our breeder cave contain thousands of terrestrial gastropods with burn marks indicating systematic cooking. Fresh snails provide 16 grams of protein per 100 grams, plus calcium and iron. They collected after rain when snails emerged to feed, using the shells as natural cooking vessels. Hot coals heated the shells from below, steaming the meat inside. One collecting session could yield 8 pounds of snails, enough protein for 4 people for one day. The cooked shells were cracked systematically to extract meat, always at the spiral point for maximum access. Seasonal collecting occurred between April and October, when snails were most active. Snail collection required understanding of behavioral patterns and habitat preferences. Different species emerged at specific times after rainfall, some within minutes, others after hours. Collectors learned to read weather signs, timing expeditions for optimal gathering windows. They knew which limestone areas supported the largest populations and rotated collection sites to prevent overexploitation. Specialized tools included pointed sticks for extracting snails from crevices and woven baskets that allowed drainage while preventing escape. The cooking technique was refined over thousands of years. Coals had to reach specific temperatures, hot enough to cook the meat but not so hot that shells cracked and lost the cooking liquid. Cooking time averaged 12 to 15 minutes for optimal texture. Overcooked snails became rubbery and difficult to digest. They ate snails immediately after cooking when meat texture was perfect. The calcium-rich shells were often ground and mixed with other foods to supplement mineral intake during periods when other calcium sources were unavailable. Number 12. Brain tissue from hunted herbivores accessed through skull base. 47,000 years ago at La Quina rock shelter, Neanderthals were smashing open reindeer skulls to extract brain tissue within hours of successful hunts. Cut marks on skull bases show systematic access through the foramen magnum, the natural opening where spine connects to brain. Fresh brain tissue provides 140 calories per 100 grams, plus essential fatty acids, crucial for neural development in growing children. They use stone hammers to create controlled fractures, never damaging the brain inside. Reindeer brain weighed approximately 400 grams, enough essential fats for 2 adults. The technique required anatomical precision because damaged brain tissue spoils rapidly. 37 reindeer skulls from the site show identical access patterns, suggesting specialized knowledge passed between generations. Brain extraction was a specialized skill requiring years to master. Apprentice hunters practiced on smaller game before attempting large herbivore skulls. The technique involved precise percussion at specific stress points where skull bones were thinnest. Too much force shattered the skull and contaminated brain tissue with bone fragments. Too little force failed to create adequate access. Masters could extract intact brains in under 5 minutes, using stone hammers weighing exactly 1 to 2 pounds. The fatty acids in fresh brain tissue were essential for winter survival when plant-based omega oils were unavailable. These fats maintained cell membrane integrity during extreme cold stress that killed less adapted populations. They consumed brains raw within 3 hours of death when fat content remained optimal. Brain tissue spoiled faster than any other organ, becoming toxic within 6 hours at ambient temperature. But here's what changes everything. In 2019, researchers analyzing soil cores from La Chapelle-aux-Saints found something that reframes this entire survival story. Buried 3 feet below the main occupation layer, they discovered a cache of 263 hazelnuts, still intact after 40,000 years, arranged in a perfect spiral pattern around a central hearthstone. The nuts were buried with systematic precision, exactly 18 inches apart, each cache marked with a flat limestone slab. This wasn't random food storage, this was engineered survival architecture. Your Neanderthal cousins weren't just eating to stay alive, they were building insurance against extinction, one calculated calorie at a time,